Let's discuss how graphs help manage context to boost accuracy, improve explainability, and future-proof your AI systems. We will demonstrate this with an employee and talent agent that is responsible for assisting with skills analysis and talent search. For starters, we'll need to source resume data, which we currently have in PDF form. Just parsing the text and using vector search alone on the resumes isn't enough, as this results in partial, irrelevant, and often inaccurate responses. For example, the agent cannot correctly answer even simple questions, such as how many Python developers do I have? With the agent searching for text for Python developers, being limited by the max number of documents it can return, in this case 5, then using that as the answer to the question, even though we have many more than 5 total Python developers in our database. While this simple problem can potentially be worked around with document metadata, not all problems can. For example, consider a slightly more complex question about summarizing the technical talent and skills distribution. In this case, all the agent can do is plug generic search terms, such as technical skills and programming languages. While it provides a seemingly coherent and informed response, it is really limited to just a fraction of the resumes that happen to be retrieved by the generic search, rendering the response incomplete at best and likely highly inaccurate. At the end of the day, this will not scale. Regardless of how sophisticated an LLM or advanced an agentic framework or platform we use, all our responses will remain incomplete and inaccurate, because the core of the problem is that we aren't organizing and managing our context so it can be efficiently retrieved for our agent to understand and intelligently reason over. So let's solve this problem with a knowledge graph. We'll begin by extracting entities from our resumes into a graph data model to help answer the majority of our expected questions. We can start simple here and iterate more later as needed. No need to model and migrate all our data at once. In this case, we'll just model people as nodes. Those people can have skills such as Python development, SQL, and other technical capabilities, as well as things they have accomplished, such as projects they have built, shipped, managed, etc., which can exist in different domains and be of different work types. All the code for this entity extraction is contained in the linked repo. Once extracted into Neo4j, the data will look like this, with people nodes here containing resume text and other metadata connected to each other through skills, as well as things, aka projects and accomplishments, which are in turn connected to common domains and work types. Once the data is in this format, we can use Cypher, our graph query language, to retrieve data through pattern matching. For example, we can match patterns like this, that looks for people building things in different domains, and limiting in this case to the first 20 results. And we'll see here we get back patterns where we have a person who builds different things inside of different domains with various examples. We can make these query capabilities available to virtually any AI system through our MCP server for Neo4j and labs. So let's see what that looks like in Claude Desktop. So you can see here, I've configured my MCP server for Neo4j. This will allow me to get the schema, the data model we were just looking at, as well as execute Cypher against our database. I can go ahead and ask my developer Python headcount question. The first thing that it will do is get our schema for context. You can see the schema response there. And then it will formulate a query based off that schema to retrieve Python developers. You can see the pattern matching that it did there. And then it will retrieve the total headcount, which is 28 developers or 28 people with Python skills, which is the correct answer. You can see here it will explain its exact retrieval logic, and then it will return that list with additional details as needed by department. We can also ask our more complicated question around technical talent and skills distribution And we'll see how making this context available creates interesting multi-hop logic as well, where Claude in this case will be able to run multiple queries back to back to get all the information that it needs, matching various patterns. For example, looking at skills again here. Then looking, for example, at department information, looking at different types of accomplishments or things people are working on, going down the list further for various different types of patterns. Once that is retrieved, Claude will go ahead and create an interactive dashboard for us. This might take a second to put together the UI. Alrighty, we'll see here that we also get a complete explanation of the data retrieval and analysis that it took down to the technical query level. And then all of our key insights are also put into this dashboard where we see a summary of our total employees, unique skills, department distributions, project domains, a distribution of technical skills, work types, going on and on. By chaining together this multi-hop logic using the context available inside of the graph database. Now we can extend this even further, creating query templates that use variable length pattern matching to score similarities between people, to answer backfilling type questions. Graph databases also make it easy to add data and extend your schema, enabling us to include additional structured data, such as from an HR information system, to answer different types of collaboration and career path questions. So we can see by concrete example how a knowledge graph in Neo4j helps manage, organize, and retrieve context, improving agent intelligence to deliver explainable, accurate responses, while providing the flexibility to continuously add structured and unstructured data, future-proofing your AI systems. Be sure to get started with Neo4j today to build production-ready AI.